Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to work with composition of functions. Basically, the idea here is that we're substituting one function into another function. We write it the way that it's shown on the screen. This little circle in between f and g is the composition operator, and it's read as the word of. So this is f of g of x. And that means that g of x, the function that's listed second, is the inner function, and that's going to get substituted into the outer function, which is f. Now the order matters here because g of f of x means that we're going to substitute f of x into g of x, and usually that gives us different results, although it won't always do that. So keeping track of the order is really important. In the first example, we've got f of x equals the square root of x plus 9, and g of x equals 6 over x. And we're going to do a composition involving values. So first I've got f of g of -3, and I find that it works better for me to rewrite that as f on the outside, g of -3 on the inside. Now I need to figure out what g of -3 is, so I'm going to do that over here to the side. G of -3, the function was 6 over x, so that's 6 over -3, which is -2. That value of -2 is going to come back in here to replace g of -3. So this becomes f of -2. Now I just need to substitute that value into the function f. And that function was the square root of x plus 9. So again, a good idea is to rewrite it, but replace the variable x with a set of parentheses. What am I going to write in those parentheses? In this example, it's going to be -2. -2 plus 9 is 7, and we do not know the square root of 7, so the exact value is good here. F of g of -3 equals the square root of 7. Now we're going to reverse it in part B, and we're going to use a value of 7 instead of -3 to begin with. So I'm going to start with g of f of 7. So I need to figure out what is f of 7. That's the square root of x plus 9, or 7 plus 9, which is the square root of 16, which is 4. So I can take f of 7 and replace it by all of it by the number 4. So this becomes g of 4. I substitute 4 in for x in the function 6 over x, and 6/4 simplifies to be 3/2. So that's how we do it. This last one, you can think of it this way. We've got a function g of x. We've got another function f of x, and we plug 7 into f of x. That gave us an output of 4, which then went into function g of x and gave us 3/2. So it's kind of like an assembly line of functions, if you will. Now that we've done it using values, we're going to do it using a general variable x instead. So now we're going to work with the formulas rather than substituting along the way. This time, f of x equals the square root of x minus 4, and g of x equals 3x plus 7. And I want to find f of g of x, so I'm going to start by writing that as f of g of x. I'm going to replace g of x by its formula, so that's f of 3x plus 7. And in terms of the domain, which we do need to figure out, this is the first place we check the domain. Are there any values that we cannot substitute for x? No, it's just a polynomial. It's a linear polynomial, a linear function. So any value can go in for x, so there's no restrictions on the domain yet. Now we're going to substitute this into the function f. And the formula for the function f is the square root of x minus 4. Put 3x plus 7 in there. Simplify what's on the inside. It's the square root of 3x. 7 minus 4 is 3, so 3x plus 3. That's the function. I do have to check the domain here as well. And so in this second spot, what we're looking for are values that are in the domain at both checkpoints. So here it's going to be in the domain of g of x, and at the same time it's going to be in the domain of that composition of functions as well. Because now we have a square root, we know we can only take the square roots of non-negative numbers. So for the domain, I have to set 3x plus 3 to be greater than or equal to 0. And solve that. 3x is greater than or equal to negative 3. Divide by 3, x is greater than or equal to negative 1. So the domain for this function is negative 1 comma infinity, including the negative 1. Now we're going to do it in the other order. We're going to find g of f of x, and we're going to notice that the result is not the same as our first example. So this is g of f of x. Replace f of x by its formula, g of the square root of x minus 4. When I check the domain here, x minus 4 has to be greater than or equal to 0. So I know that x has to be greater than or equal to 4. Now I may restrict my domain even further in a moment, but that's where I'm starting. Now I'm going to plug that into the function g, which was 3 times the input x plus 7. Put in the square root of x minus 4 there. There's nothing I can do to simplify this. I cannot distribute the 3. There are no like terms to combine. So it's simply 3 square root of x minus 4 plus 7. The domain has the same restrictions. So the domain is 4 comma infinity. In problem 7, we're working with two functions. One's quadratic, one is linear. There's not going to be a domain issue here because we can substitute into these functions without any concern at all. And when we combine them, no matter what they combine to be, it's going to be a polynomial as well, so we can substitute there. So the domains for both of these cases are going to be all real numbers. But the formulas are going to be different, just like they were in the last problem. Well, I guess I didn't mention that. But if we look at the two formulas, those are not the same. And so you've got to be really careful about making sure that you plug the right formula into the right formula in the right place. Number 7 again, f of x is x squared plus 4x plus 8. G of x is 2x minus 15. We're going to start with f of g of x. Replace g of x by its formula. That's f of 2x minus 15. Now I want to write down the fill-in-the-blank form of f of x. X squared, so something squared, plus 4x, so that's 4 times something, plus 8. And in those parentheses, I'm going to put in 2x minus 15. 2x minus 15, to square that, is 2x minus 15 times itself. And we multiply that by distributing, so I'm going to do that. 2x times 2x, that's 4x squared. 2x times negative 15, that's minus 30x. Negative 15 times 2x is also minus 30x. Negative 15 times negative 15 is 225, positive. Distribute the 4 next. 4 times 2x is 8x. 4 times negative 15 is minus 60. And then we've got plus 8. A lot of terms, need to combine them down. There's only one x squared term, so I'm going to copy that down, 4x squared. For the terms containing x, negative 30, and positive 8. Negative 30 minus 30 is negative 60, plus 8 is negative 52. So minus 52x. And then finally, for the constants, 225 minus 60 plus 8, that is, 173. And there's your composition of those two functions in that order. That's actually the more difficult of the two. When the outer function is more complicated, the composition is more complicated. In this next example, the outer function g is just a linear function. It's going to be easier to work with. This is g of f of x. I'm going to replace f of x by its formula. G of x squared plus 4x plus 8. Write down the fill-in-the-blank form of g of x, which was 2x minus 15, so 2 times some parentheses minus 15. X squared plus 4x plus 8 goes in the parentheses. All we have to do here is distribute and combine like terms. Distribute the 2 to get 2x squared plus 8x plus 16 minus 15. Combine like terms, and we get 2x squared plus 8x plus 1. And if we compare that back to the first problem, we see that the results are different. So one more time, the order that you work in is really important. One last example of this type. These are a little more complicated because these are rational functions. We have f of x as 6 over x minus 3. We have g of x as 10 over x. So, and we will have to worry about the domain here too. Part A, f of g of x becomes f of 10 over x. Putting in the formula for g of x into those parentheses. Now here we've got 10 over x, so I know that x cannot be equal to 0 because that would force us to divide by 0. Let's see if there's any other restrictions on this domain. Put the form for x, that's 6 over x minus 3. And that becomes 6 over 10 over x minus 3. Let's clear the fractions by multiplying the numerator and the denominator by x. That gives us a numerator of 6x. In the denominator, x times 10 over x is just 10. X times negative 3 is negative 3x. That's the function. Now, we have one more domain problem to worry about. 10 minus 3x cannot be equal to 0. Negative 3x cannot be equal to negative 10. And when we divide, we see that x cannot be 10 thirds. So the domain would go from negative infinity to 0, union 0 to 10 thirds, union 10 thirds to infinity. So we're just excluding 0 and 10 thirds. Let's work it in the other order. So this time we've got g of, let's write that a little better, g of f of x, which is g of 6 over x minus 3. Here, x cannot be equal to 3 because then we would have a denominator of 0. So we throw 3 out first. Then we're going to substitute this into the function g. So this is going to be 10 over 6 over x minus 3. When we divide by a fraction, like we are here, we can multiply by its reciprocal. So this is the same as 10 times x minus 3 over 6. The 10 and the 6 have a common factor of 2 that we can divide out, like so. And we end up with 5 times x minus 3 all over 3. Notice that there's no variable in the denominator here, so there's no other domain restrictions to worry about. X cannot equal 3. And the function is 5 times the quantity x minus 3 all over 3. Now, 3 looks like it's in the domain of the second part of this function, right? If we plug in 3 for x, we would get 5 times 0 or 0 over 3, which equals 0. But 3 into the function f is undefined. We'd have 6 over 0, so it's not in the domain, even though it's in the domain of the last function. All right, one last one to go. This is kind of working it backwards. I'm going to give you a function, And I want you to tell me two functions that could be combined to give this. So the inner function is g of x, the outer function is f of x. And when I look at example A, look at what I see on the inside. That's 3x plus 5. That's my function g of x. Now, if I were to replace that just by x, think about replacing that by x, that'll tell us our outer function, which would be 2x squared minus 8x plus 13. Right? Replacing this and this with an x. Right, let me bring that back for you. In part B, I've got f of x, f of g of x is 1 over x plus 3 plus 9. There's a lot of ways you could do this. I'm going to propose this one. If I think of it like this, I could let g of x be 1 over x plus 3, and then f of x would be that plus 9. So I can think of that as x plus 9. There are more than one way to break it down by composition. These are just one example for each one. All right, that's it for composition of functions. I will see you in the next section.